Page 4 is about finding the zeros of a quadratic equation using what they call the quadratic formula. This equation is kind of big. It's kind of easy to make mistakes when you are doing this algebra. On the other hand, it's probably good practice if you do this a few times because this equation is so complex. If you can substitute values into this equation without making mistakes most of the time, you're doing pretty good. Okay? So I'm going to go through all these examples here, and then why don't you follow along. Feel free to stop the video and think about it or write things down. Don't just let me drone on with you not writing anything down. Okay, it's important for you to write this stuff. Okay, so first I'm going to do this first one, x squared minus 4x minus 3 equals 0. Normally you might do this with factoring, but they're saying, hey, this time I want you to use quadratic formula. So quadratic formula, you can see, finds the appropriate value of x, which makes this equation 0. Okay, graphically, what you're going to see is, oh, when does this parabola cross the x-axis? When does it equal height equals 0? Okay? How do we find that? Well, you can factor, or you can use quadratic formula. Here we're going to use quadratic formula. So first we're going to rewrite quadratic formula. It helps us to remember it and rewrite it correctly. You don't know how many times I've seen people who copy it wrong and lose points because they copied it wrong and they got everything else wrong even though they did the substitution. Okay, so one thing that might be confusing is there's no a value, right? There's no a value that corresponds to ax squared. There's just blank x squared. Remember, if there's no a value, it's a 1. Okay, so the b value here is -4. The c value is -3. So I'm going to substitute those three values into a, b, and c here. Negative b, you see I'm really careful. Whenever I substitute into an a, b, or c, I put parentheses around negatives. And you'll see why in a second. B squared, -4 squared, minus 4 times 1 times -3. Saying, why is he putting parentheses around everything? 2 times 1. Okay, so now we're going to do the algebra here. You see we have negative of -4. Negative of -4 is positive 4. So I'm going to have 4 plus or minus. Then inside the radical I have -4 squared. -4 squared is -4 times -4, so it's positive 16, right? Now you see why I didn't put -4 squared with no parentheses. -4 squared is -16. So that's totally different, right? So it really depends on whether you put parentheses or not. Whenever you're substituting into a variable like a, b, or c, you need to put parentheses around negative numbers. -4 times 1 times -3 gives us positive 12, right? And then the denominator is 2. Okay, now we can maybe add this together. So it's going to be, there's two solutions. One is going to be 4 plus the square root of 16 plus 12. 16 plus 12 is 28, right? Square root of 28 divided by 2. And then the other option is 4 minus the square root of 28 divided by 2. Okay? This could also be simplified. It could be 2, 4 over 2 is 2, plus square root of 28 divided by 7, or 28 divided by 2, you could actually, 28 is actually the same as square root of 4 times 7. Square root of 4 is 2. So square root of 28 is actually equal to 2 times square root of 7. 2 times square root of 7 divided by 2 is square root of 7. So the other solution is 2 minus the square root of 7. And if you didn't understand that, that's okay. You don't have to simplify it. But come to homework club sometime and let me review that with you. Okay, so the two solutions are 2 plus square root of 7 and 2 minus square root of 7. I'm just going to shrink this down here so I have room to do other problems on this page, okay? Alright. Now, we can kind of see why we did not do that problem with factoring. How could you ever do a problem with factoring and end up with 2 plus square root of 7 and 2 minus square root of 7 as roots? You're not going to, right? So you're not going to do that problem with factoring for sure. Okay, now we're going to do C. C is x squared plus 1 equals 4x. And you're going, well, that doesn't even look like the other one. I want everything together. I want the x squared term, the x term, and the constant term all together. And now this is split on two different sides. So what you need to do is you need to move the 4x to the left side, so you subtract 4x from both sides. You end up with x squared minus 4x plus 1 equals 0. And that gives us what we really need, which is we have on the right side 0 and on the left side the quadratic equation. Now we can proceed with using the quadratic formula. Okay, let's identify our a, b, and c. The a is 1, the b is negative 4, and the c is plus 1. Okay, so let's put it in the quadratic formula. X equals negative b, which is negative 4, I'm using parentheses again, plus or minus the square root of b squared minus 4 squared minus 4 times a, which is 1, times c, which is 1. Okay, all over 2 times 1. Alright, now working this out. Negative minus 4 minus negative 4 is equal to positive 4, plus or minus. And then we have here negative 4 squared is 16 minus 4 times 1 is just 4 divided by 2. Okay, so I got 4 plus or minus the square root of 16 minus 4. That's 4 plus or minus the square root of 12 divided by 2. Okay, so I can simplify that. It'll be 2 plus or minus the square root of 12. Square root of 12 is actually the same thing as square root of 3 times square root of 4, which is the same thing as 2 times the square root of 3. I can cancel out the 2's and I end up with 2 plus or minus the square root of 3. And again, if you don't understand how I did that, let's work on that homework club sometime. You did that in the past. Okay, I'm going to put the work for C over here. Now I'm going to do E. E looks pretty straightforward. Everything's on the left side already. The A looks like it's a 1, the B is negative 4, and the C is 2. So let's start substituting in. So that would be x equals negative b, which is a negative minus 4, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is 1, times c, which is 2. I won't even write the 1 there. Who cares about the 1? It's multiplied by 1. It gives you the same thing. The denominator is 2 times 1, 2a, so I'm just going to leave 2. Okay? Now I'm going to work out the arithmetic here. Negative 4 squared is 16, minus 4 times 2 is 8, all divided by 2, which is the same thing as 2 plus or minus. Square root of 16 minus 8 is square root of 8, divided by 2. Square root of 8 is the same thing as 2 times square root of 2, divided by 2 is square root of 2. Okay. Now, in IB, they don't mind that much if you don't simplify, so if you're not comfortable with simplifying these fractions and radicals, you can leave them the way they were, and you might not lose any points. G. 3x squared, 3x plus 1 quantity squared equals negative 2x. Now that looks totally not what we want, right? So the first thing we're going to do is we're going to try to get 0 on the right side, everything else is on the left side. So let's do that. We'll put 3x plus 1 squared, and we'll subtract a negative 2x from both sides, so we'll add 2x to the left side, and then we'll get equals 0. Now we need to combine all this together to make a standard quadratic equation. So we're going to expand 3x plus 1 so that we can combine it with the 2x. So we're going to have 3x squared plus 2 times 3x times 1 plus 1 plus 2x equals 0. 3x squared is 3x times 3x, which is equal to 9x squared. 2 times 3x is 6x. Add that to 2x, and you get 8x plus 1 equals 0. Now you're seeing why I said that this class requires pretty good algebra. Now we're going to identify A, 9, B, 8, C, 1. Now remember, it's x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so we're going to put negative 8 plus or minus the square root of b squared, which is going to be 64, minus 4 times a, which is 9, times c, which is 1, so it's 4 times 9, 36, divided by 2 times a, 2 times 9, which is 18. I'm starting to skip steps now. I hope I'm not losing you. You go ahead and do every single step. Just pause and do every single step. Make sure you get the same thing I do. 64 minus 36, that is about 28. There's 28 again. They like that. Square root of 28, don't they? Okay, and then negative 8 divided by 18. You can reduce these fractions if you want to, but it's no big deal if you don't. I would say then I would put negative 4 divided by 9, right, plus or minus the square root, and then I have square root of 28, so that's square root of 28 is the same thing as 2 times square root of 7, so that's square root of 7 divided by 9, okay, so that's it for G, okay, so you see, basically all we had to do was put the values for A, B, and C into the quadratic formula, and then eventually we're going to get our two values for where the parabola intersects the x-axis, okay? And sometimes it might not look like it's two values. If you look at that really quick, you might think, oh, that's only one value, but you got to pay attention to the middle. It has plus or minus. So really, when you write this, you're saying, oh, one of the values is negative 4/9 plus square root of 7 divided by 9, and the other one's negative 4/9 minus the square root of 7 divided by 9, okay? All right, number 2. Rearrange the following equations so they are written in the form ax squared plus bx equals 0 plus c equals 0. Then use the quadratic formula to solve exactly for x. Okay, so these aren't quite as nice. Before they had some problems here where it was all set up. Like this is all set up. We didn't even have to do anything except for identify A, B, and C. Right? How did we identify A? It was the number before the x squared. How did we identify B? It was the number before the x by itself. It was x to the first. And how did we identify C? It was the constant term that had no x's in it. Okay? It doesn't matter the order. It just matters what is getting multiplied times the coefficient. Okay? Now here I got things multiplied together. That's not what we want. We want something x squared plus something x plus something. And that's not what this looks like. So we're going to have to expand x plus 1 times x minus 1. And we're going to have to, let's see, x times x is x squared. 2x is 2x. I'm doing FOIL. X times negative 1 is negative x. And then 2 times negative 1 is negative 2. I expanded it. 2 minus 3x. Now I'm going to subtract 2 from both sides. And I'm going to add 3x to both sides. And by doing that, the right side is going to become 0. The left side is going to become x squared plus 5x minus 4 equals 0. And the 5x minus x combines, it makes 4x, right? Okay, and now it says to use the quadratic formula with this. What's A? A is 1, B is 4, C is negative 4. I'm going to put the quadratic formula here, negative b plus or minus the square root of b squared minus 4 times 1 times c, which is negative 4. Do you see how I put it with the parentheses there? You can't just write 4 next to the minus 4 saying it's multiply, because that would look like 4 minus 4, which is subtraction, right? Divided by 2a, which is 2, because a is just 1. Now I'm going to simplify a little bit. Negative 4 divided by 2. 16 minus 4 times negative 4 is 16 plus 16, 32. Okay. Negative 2 plus or minus. Square root of 32 is actually equal to 2 times the square root of 8. And then I divide that by 2 and I'm left with just square root of 8. Okay. Alright, so that was A. Let's do E. Okay, so E has x minus 1 over x equals 1. And now you're saying, my gosh, this doesn't look like a quadratic equation at all. The thing that makes it a quadratic equation is, let's get this x out of the denominator, because that kind of confuses things. So we're going to multiply both sides by x in order to get that x out of the denominator. On the left side, we're going to end up with x squared minus x divided by x equals, and then 1 times x is x, right? What about x over x? What does that equal? It equals 1, of course. X squared minus 1 equals x. Now we're going to move everything to the left side, leave 0 on the right side, which is usually what we need, right? So we're going to have x squared minus x plus minus 1 equals 0. Okay, now what's our A? Our A value is 1. What's our B? It looks like there's nothing there, but actually, if there's nothing there, it's a 1, so it's negative 1x. So our B is negative 1. Remember, the B is not negative 1x. B is multiplied times x, so the x is not part of the B coefficient. Negative 1 is C. Okay, so we got 1, negative 1, negative 1. So now we're going to substitute that in. X equals negative of negative 1 plus or minus b squared, which is negative 1 squared, minus 4 times a times c, which is 4 times 1 times negative 1. I won't even write the 1 because it doesn't do anything, right? Divided by 2 times 1, which is 2. Okay. Now I have 1 plus or minus the square root of negative 1 squared is 1, minus 4 times minus 1 is positive 4, divided by 2. Okay, divide both of them by 2. If you don't understand how do you do that with fractions, come after school sometime. 1 plus 4 is 5, so it's square root of 5 divided by 2. So there's our answer right there. Okay? There's your answer for that one. There's your answer for that one. Hope all these are right. Okay. X minus 2's quantity squared equals 1 plus x. So again, we need to put everything on the left side, leave 0 on the right side. So we need to expand x minus 2 quantity squared. So we're going to expand that. We get x squared minus 4x plus 4. I'm doing FOIL here. And then I have 1 plus x on the other side. Okay. Then I'm going to subtract 1 from both sides. And I'm going to subtract x from both sides. And I'm left with x squared minus 5x plus 3 equals 0. Okay, now what's my A? My A is 1, my B is negative 5, my C is positive 3. I'm going to substitute all that in. So x equals negative B, which is negative of negative 5, plus or minus B squared, which is negative 5, quantity squared, which is 25, positive 25, minus 2 times A, which is 1, times C, which is 3. Okay, all divided by 2 times 1, which is 2. Subtract negative 5 is positive 5. Plus or minus 25 minus 6 is equal to 19, so plus or minus 19, and both of these are divided by 2. Okay, and that is the answer for C. And that is the end of page 4.